The next thing we want to discuss is implicit differentiation. So it's motivated by the following idea. We have x cube plus y cube equals to 3xy. This is called folium of Descartes. And we need to find out equation of tangent line at point 3 by 2 comma 3 by 2. Now note that here y is not explicitly written in terms of x. So far we have done y equals to f of x, right? Then you would basically go dy by dx equals to f prime x. However, in this case, you can't really separate y, or usually you wouldn't want to separate y and be able to differentiate it. Okay. So taking derivative in such scenario is called implicit differentiation. So taking derivative of an implicit equation is called implicit differentiation. The process is called implicit differentiation. Let's see the following. So a function in two variables, x and y, may have more than one solution for y in terms of x or x in terms of y. These solutions are said to be implicitly defined by the equation. So these functions are not explicitly defined. Now, what is an explicit example? Explicit function would be, let's say, y equals to x squared. Here, y is explicitly defined in terms of x. However, if you take x squared plus y squared equals to 1, this is not an explicit equation, because you have, for every x, you will have two values of y, right? So y is not even function of x, right? So y is not a function is not a function of x, right? So let's look at few examples. X squared plus y squared equals to 1. Yeah. So if you draw this, so if you look at this, for every x, there are how many values of y? In this case, at least, for many x's, there are two values of y, right? For this input, there are two output values. Yeah. So here y is not a function of x. Now one may argue, oh, can we try to write x as a function of y? That is also not possible, because for one y there are two x, right? So therefore this is not, x is not function of y is not a function of x. However, can we draw a tangent line here? Yes, we can. We can draw the tangent line at this point. That means we should be able to find out the equation of tangent line. That means we be able to find out the slope of the tangent line. That means we should be able to find out dy by dx in this case. Okay. So the idea lies as follows. So use chain rule to differentiate both sides of equation, thinking x as an independent variable. Solve the resulting equation for dy by dx. So let's look at the first one. Find the curve x cube plus y cube equals to 3xy is called folium of Descartes. Find the equation of tangent line at 3 by 2, 3 by 2. So how do we go about it? Well, we'll differentiate both sides. So we'll not try to solve for y in terms of x, but we'll differentiate both sides. Both sides with respect to x. So notice the following. So let's say what is derivative of y squared with respect to x? So let's work this out. So suppose y is your g of x. What is d by dx of g of x squared? by chain rule is going to be 2g of x multiplied by g prime of x, right? Now instead of g of x, write y. What do you get? D by dx of y square is going to be 2 times, instead of g of x, you have y, so 2y, and then you have g prime x is going to be, what is g prime x? dy by dx. So derivative of y square is 2y dy by dx. This is the consequence of the chain rule. Yeah. Similarly, what is derivative of, what is d by dx of y cube? Is going to be 3y square dy by dx. Okay. So now differentiate both sides with respect to x. So we have d by dx of x cube plus y cube equals to d by dx of 3xy. Yeah. Again, what are we trying to find? We are trying to find the equation of tangent line, the point 3 by 2 comma 3 by 2. The point is given, you are looking for the slope, and the slope is given by dy by dx. All right. So what is derivative of x cube is 3x squared. What is derivative of y cube? 3y square dy over dx. Here 3 can come out. Now we have x multiplied by y. So we can employ the product rule here. So x times derivative of y plus y times derivative of x, which is 1. Now the differentiation is done. We need to isolate dy by dx. So we'll separate dy by dx on one side. So let's look at the terms which have dy by dx and bring them on one side. So we have 3y square dy by dx. Now when this goes on the other side, this 3 is multiplied already with it. So 3x dy by dx equals to 3y minus 3x squared. And if you take dy by dx common, you get 3y squared minus 3x equals to 3y squared minus 3x squared. So this would give me dy by dx equals to 3, there's an error, so 3y minus 3x squared divided by 3y squared minus 3x. You can pull 3 common from both numerator and denominator. So you have 3y minus x squared, 3y squared minus x. This 3 and this 3 can cancel off. We have y minus x squared upon y squared minus x. So this is your dy by dx. Now we need to find out the slope. So m is going to be dy by dx evaluated at 3 by 2 comma 3 by 2, which is going to be, put 3 by 2 inside, so 3 by 2 minus 3 by 2 square divided by 3 by 2 square minus 3 by 2. Now, so notice that top is not 0, bottom is not 0, but top is negative of bottom, right? So you will get that, take minus sign out, you have 3 by 2 square minus 3 by 2 divided by 3 by 2 square minus 3 by 2, and then you can see that you can cancel these, you get minus 1. I mean, you could have calculated it and gone that route as well, but you can go. So therefore, the equation of tangent line is y minus y1. What are the points given to us? 3 by 2, 3 by 2. So y minus 3 by 2 equals to m, which is a slope, times x minus 3 by 2. So this is your equation of the tangent line at that point. So this is the scenario. You have basically a spherical tank and the radius is 10. So at any point, this is center. Any connection to the surface of the sphere is going to be 10. All right. And then what else do we have? We have depth of the water is 5 feet and it's decreasing. So let height of water be h. And so the surface of the water is circular, and so let that radius of that circle be r. Now we want to connect h and r. So for that, notice that if this is h, this part is going to be 10 minus h. Now we already know what is this length. This length is 10 because it is the radius of the sphere. So if you use Pythagoras theorem, you get 10 minus h square plus r square equals to 10 square. Now differentiate both sides with respect to, so differentiate both sides with respect to, so with respect to what? Now note that here we are given what dA, we are given the rate of change with respect to time, right? So we'll differentiate with respect to t. Yeah. And note that h and r both are function of t. Why? Because as you keep changing time, the water level is dropping, r is changing, h is changing, but they are changing with respect to time, right? So with respect to t, note r and h are functions of t, right? Both of them are functions of t. So what is the derivative of this? So this is going to be 2 times 10 minus h times derivative of 10 minus h is going to be what? Let me just write it down. Derivative of 10 minus h. Similarly, derivative of r square is 2r times dr by dt equals to 0. This is a consequence of the chain rule. Now, if I do this part, I get 2 times 10 minus h times minus dh by dt plus 2r dr over dt equals to 0. Now, what are things given to us? We are given few things. When the depth is 5, it is decreasing at the rate of 3 feet per second. So what is given to us? When h is 5, dh by dt is 3 feet per second, but it is decreasing, so minus 3 feet per second. Okay, so we get what? 2 times 10 minus, so where h is 5, dh by dt is minus 3. However, we also need r at that point, right, to find out dr by dt. So what is r? So let's go back here. So when we have also when h is 5, how do we get r? We'll use this theorem again, Pythagoras. So we get h is 5, we get 10 minus 5 square plus r square, that's what we need to find out, equals to 10 square. So this implies r square equals to 10 square minus 5 square, which is same as 100 minus 25, so 75. So therefore, r is square root of this, square root of 75, which is 5 root 3. So therefore, let's substitute this back in the equation. What do we get? If you put it back in this equation, we get 2 times 5, because h is 5, minus dh by dt. So we get minus of minus, we get plus 3 plus 2r, which is 5 root 3 times dr by dt equals to 0. So now bring this on the other side. So when you bring this on the other side, you get 2 times 5 times 3, and then you divide, you get a minus sign on the top, you get 2, 5 root 3. And then when you cancel off, you'll see that 1 root 3 will survive. So we get minus root 3 feet per second. So the next thing we want to discuss is a differentiation of inverse functions. So what are inverse functions? Recall. If f is a 1-1 function, you can have an inverse of it. So suppose f is 1-1 function and it's differentiable, then the inverse is also differentiable. Okay. So let's use the implicit differentiation to find out what the inverse derivative look like. So we know that f inverse of x is x, right? Now take derivative on both sides. So if we take derivative on both sides, on this side you will get 1, right? So this side you get 1. On the other side you have to employ the chain rule. So let's see. F prime f inverse of x multiplied by f inverse x prime equals to 1. So this would give me, keep f inverse x because we want to find out derivative of f inverse x, move everything on the other side. So we get what? F inverse x prime is 1 upon f prime of f inverse of x. So I just move this on the other side, and so we got the derivative of. Now let's use this to find derivative of sine inverse x. So what is derivative of sine inverse x? So in this case, let y be sine inverse x. What are we interested in? We are interested in dy by dx. So dy by dx is what we want to find out. Now either we can use this theorem right away on how to find the derivative, or we can do it in the following way. So y equals to sine inverse x. This means sine y equals to x. Now this implies, what does this implies? Take derivative on both sides with respect to x. So derivative of sine y is what? Cos y multiplied by dy by dx because of the chain rule. And on the other side, you get what? Derivative of x is 1. So this implies dy by dx equals to 1 upon cos y. However, we wanted the derivative. So the derivative part is done now. However, it makes sense to write derivative in terms of x. So then we can convert cos into what? Into sine. For that, we have the following formula. We have sine square x plus cos square x is 1, right? So you have sine square x plus cos square x equals to 1. So you get from here, you get cos x equals to plus or minus square root of 1 minus, oh well, we are replacing cos, so in terms of sine, so we get 1 minus sine square y. So we get cos y equals to plus or minus square root of 1 minus sine square y. However, notice the following. Your y, so where is your, so sine inverse is a function from where to where? So sine inverse is a function from, so sine inverse is a function from minus 1, 1 to minus pi by 2 to pi by 2, right? So your y is sine inverse x. So y belongs to minus pi by 2 to pi by 2. Yeah. Now, in this case, what can you say about cos y? In this range, cos, how does cos looks like? So cos is basically, so cos is positive. Yeah. So cos y is greater than equal to 0, right? So in this case, what do we get? We get this is going to be plus 1 minus sine square y. Yeah. So of course, you can't have cos y to be 0, so you will be excluding those points. Yeah. So you will be exclude pi by 2 and minus pi by 2. Yeah. All it means is that at those points, the function is not differentiable. Right. So we get what? Now here we got, so this is going to be 1 upon square root of 1 minus. So what do you have? You have 1 minus, instead of sine y, I'm going to write x. So 1 minus x squared. So this is how the whole story goes. Similarly, you can prove that cos inverse of x is minus 1 over square root of 1 minus x squared. Tan inverse of x is 1 upon 1 plus x squared, the derivative of it. And derivative of cot inverse of x is minus 1 upon 1 plus x squared. So this is how it works out. Yeah. If you want, we should do this problem, tan inverse x. Okay, so let's do tan inverse of x. So let y be, so problem C. So let y be tan inverse of x. This implies tan y equals to x. So now what do we get out of that? Take derivative on both sides. So differentiating on both sides. If you differentiate on both sides, what do you get? You get secant square y times dy by dx as a chain rule equals to 1. So therefore, dy by dx is going to be 1 by secant square y, which is going to be 1 upon, what is secant square y? In terms of tan, it is 1 plus tan square y. Now that can be put back, so you can put back tan y equals to x, so you get 1 by 1 plus x squared. So far good. Now let's move to the next problem. Determine the points on the circle where the tangent line is horizontal and where the tangent line is vertical. So first we need to find out an expression for the slope of the tangent line. So we need to find out dy over dx. So let's differentiate both sides with respect to x. So differentiate both sides with respect to x. So you get 2 times x minus 1 times derivative of x minus 1, which is 1, plus 2 times y minus 2 times derivative of y minus 2 with respect to x is going to be dy by dx equals to 0. So therefore, you get dy by dx equals to what? Bring this 2 on minus 2x minus 1, divide by 2y minus 2, and this is same as minus x minus 1, y minus 2. So now it's horizontal, so the tangent line is horizontal. When the slope is 0, right? Any line is horizontal whose slope is 0. So tangent line is horizontal if dy by dx equals to 0. This would give me that 1 upon x minus 1 upon y minus 2 equals to 0. This implies x minus 1 equals to 0. However, your y at x equals to 1, your y minus 2 should not be 0, and y minus 2 is not 0 at those points. We'll check later if y becomes 0, then we'll have to come back to this equation. So this is horizontal. This implies x minus 1 equals to 0, or gives us x equals to 1. Let's put it back in the equation to see y. And you want y minus 2 to not become 0. So when you put x equals to 1 there, you get what? You get, this will become 0. So y minus 2 square is 4. This implies y minus 2 is plus or minus 2. So first of all, at this point, this is fine. This part is okay. And we get y equals to plus or minus 2 plus 2. So therefore, y equals to 4, or y equals to 2 minus 2, which is what? 0. So y equals to minus 2 plus 2, which is 0. So therefore what the points are? Therefore points are 1, 4, and 1, 0. Yeah. Vertical is homework. You need to check when what? Y minus 2 equals to 0 and work it out when the denominator is 0. Now let's do this one. X square plus y square equals to 5. Find y double prime using implicit differentiation. So before we find y double prime, we need to find out y prime. So can you do this problem, please? So take derivative on both sides with respect to x. So derivative of x square is going to be 2x. Derivative of y is going to be 2y. Dy by dx, or y prime, whatever notation you want to use. So dy by dx equals to 0. So therefore, what do we get? We get dy by dx is minus 2x divided by 2y, which is going to be minus x by y. Now take derivative with respect to x on both sides. So d by dx of dy by dx. This is your y double prime, right? So this is going to be d by dx of minus x by y. And what do we get? Now we can use what? The quotient rule. So keep the minus 1 outside, minus sign outside. So y square times y into derivative of x minus x into derivative of y. So this becomes minus y outside, sorry, minus sine outside, y square in the bottom, y minus x times dy by dx is minus x over y, so we can substitute that back. So now you cross multiply and see what you get. So you get y times y square plus x squared divided by y, the whole divided by y. Your equal sign should be here. This is the main fraction line. This is your d square y by d square. Now this can, and then of course the minus sign outside. We'll keep that minus sign here. So this is going to be minus y square plus x squared by y cubed. So this is your derivative done. However, if you want to further simplify, you know x square plus y square on the circle is always what? Is always 5. So you can also simplify it as 5 by y cubed. So this is your d square y by dx.